Hello friends, welcome to my channel Computer Engineering Made Easy and I am Anindita. Today I will share 5 examples by which I will show you how to handle single dimensional arrays using C language. We will be using static memory allocation in this video and I will put the link to my tutorial on arrays using dynamic memory allocation in the description box. So if you are looking for arrays using dynamic memory allocation, you may skip this video. For the rest of you, let's get started. An array is a data structure, which means it is basically an organizer. Just like we use a file organizer to organize the files at our desk, an array acts as an organizer which organizes data in the computer's memory. A file organizer has got multiple partitions, and the partitions are contiguous to one another, so that the overall organization is compact and we can find the desired files easily whenever we need to. Similarly, for easy access of data, the array occupies contiguous memory locations too. In order to declare an array, we simply write the data type of the array followed by the name of the array and the size of the array in square brackets. For example, int age 5 is going to create a 5-celled array of type integer. Here, each cell is capable of holding an integer, and since an integer takes 4 bytes of space in a GDB compiler with 32-bit machine, if the address of the first cell is 0xAA00, the address of the next cell will be 0xAA04, and the following cell will have the address 0xAA08, and so on. Each of these cells are also marked by an index value which is used to refer to the cell directly. In C, the index values of an array start from 0. The same applies for C++ and Java as well. However, there are other programming languages like MATLAB where the array indexing starts from 1. There exists other languages too where the indexing can start from any value, say n, where n can even be negative, for example in Pascal. Now, variables are also capable of storing data of same type. So, why do we need an array? Well, let us take a look at an example which will make our understanding a bit more clear, as in why we need to use an array. Say, we want to store the age of only 2 students of a class. The number 2 being small and manageable, we can simply assign 2 variables to store the information. Now, what if we want to store the age information of 5 students? Even in this case, it is well manageable. Now say, we want to store the age information of 50 students. Will that be feasible? Well, even if we consider it to be feasible, if the number of students increased from 50 to 500 or even more, do you think that will be feasible anymore? Doubtful, right? Now say, even if we consider that it is feasible at this stage, imagine that we want to find the age of each student 5 years back. In order to do so, we have to deduct 5 from each of these 500 variables. And this is going to require 500 lines of code. Now, do you think it's going to be feasible? Definitely not, right? So arrays come as a solution to this kind of problem. Let's see how. This piece of C code shows how we can store the age information of n students using an array. Now, for the purpose of animation, so that you can visualize the execution process clearly, I have considered the number of students to be 5. That is, n has been defined as 5. Simply just by redefining the value of n as 500 instead of 5 in the hash defined statement will make the code compatible to work for 500 students. Now let's see how it works. As the control starts executing the main function right at the beginning, it finds an integer variable I and an integer array age declared. The size of the array is specified in the square brackets, which in this case is n, that is 5. On executing this statement, a chunk of 5 into 4, that is 20 bytes of memory, is assigned to the array age, while another 4-byte memory is assigned to I. As the control executes the for loop, first it initializes I to 0. Now since 0 is less than 5, the control enters the loop and asks for the age of the 0th student. As we enter the age of the 0th student from the console, it is stored in the address of the 0th index of the array age, which is represented as &age I, where I is 0. Say we had entered the number 21. So 21 gets stored in the 0th cell of the array age. Next, the value of I increases by 1, so it becomes 1. And since 1 is less than 5, the control enters the loop again. This time it asks for the age of the 1th student, and on entering 20 from the console, it gets stored in the 1th cell of the array age. Next again, I is incremented to 2. And since 2 is less than 5, the control enters the loop once again. Now it asks for the age of the 2th student, and on entering 19 from the console, it gets stored in the 2th cell of the array age. Now I gets further incremented to 3, and since 3 is less than 5, the control enters the loop once again. This time it asks for the age of the 3th student, and accordingly 22 is entered from the console. 22 now gets stored in the 3rd cell of the array. I next gets incremented to 4, and since 4 is still less than 5, the control enters the loop. This time it asks for the age of the 4th student, and on entering 21 from the console, it gets stored in the 4th cell of the array age. I is then again incremented to 5, and now since the condition 5 less than 5 becomes false, the control breaks out of the for loop and comes to the next for loop, where the values of each cell of the array is supposed to get decremented by 5. The second for loop also works in a similar fashion. I equal to 0 initializes the value of I back to 0, and since 0 is less than 5, the control executes the next statement, age I equal to age I minus 5. Since the value of I is 0 now, age of I equal to age of 0, which is equal to 21. On executing the right hand side of the assignment operation, we have 21 minus 5, which is equal to 16. Now executing the assignment operator, we have 16 replacing the value 21 in age 0. Thus the value of age 0 now becomes 16. Another important thing that we need to focus here is that the for loop has got no braces, which indicates that it will consider only one line of code following the loop statement to be present within the loop. That is, the statement age I equal to age I minus 5 is the only statement within the for loop. So after setting the value of age 0 as 16, the value of I gets incremented to 1, and since 1 is less than 5, age 1 equal to age 1 minus 5 gets executed. Age 1 was initially 20, so after execution of the statement, age 1 becomes 15. After this, I is incremented to 2, and as 2 is less than 5, age 2 equal to age 2 minus 5 gets executed. Age 2 was initially 19, so after execution of the statement, age 2 becomes 14. Similarly, the process continues and the values of all cells get deducted by 5. Thus, you can see the job, that is deducting 5 from each age value, can be done using only one statement in a loop if an array is used. Finally, the third loop runs to display the deducted values of ages stored in each cell of the array. Now, I said earlier that cells in an array occupy contiguous positions. Let us consider another example to see if the claim actually holds true. In this example, the first part of the code simply creates the 5-celled integer array age and stores the data in it. The next part is responsible for displaying the cell number, value of the cell, and the address of the cell. So, when the loop executes for I equal to 0, the cell number displayed is 0 and the value stored in it gets displayed along with the address of the 0th cell. Now, you may get different address when you compile this particular code as it is dependent upon your machine. But don't worry. Check the address of the 1th cell when the loop iterates for I equal to 1. Note the address of the two consecutive cells, that is the 0th cell and the 1th cell, and find the difference in their addresses. Next, execute the loop for I equal to 2 and again note the difference in the address of the 1th and the 2th cell. You will find that the difference remains constant for the cells 0 and 1 as well as for cells 1 and 2. Reiterate the loop for I equal to 3 and again note the difference for the cell numbers 2 and 3. You will find that this difference is also same as the difference of the addresses of cells 0 and 1 and 1 and 2. Furthermore, the difference value will be equal to the size of an integer in your machine because each cell over here is capable of holding an integer, as the data type of the array in this case is an integer. Let us now take a look at another example. Say we want to find the sum of the corresponding elements of two arrays and store the sum in the first array. On executing the first statement, that is int I, a15, a25, two 5-celled integer arrays are created by the names a1 and a2 along with the integer I. Now, On executing the first loop, we can store data in both the arrays just like we did in our previous example. At the end of the first loop, the variable I is supposed to have value 5. Now, we start executing the second loop. With every iteration, the statement a1i equal to a1i plus a2i is going to get executed for the values of I ranging from 0 to 4. So, when I equal to 0, and a1i equal to a1i plus a2i gets executed, it extracts the values of a10 and a20, which are 21 and 42 respectively. Now, the sum of 21 and 42, that is 63, is put back in the position a10. Next, the value of I gets incremented to 1. So, the values of a11 and a21 get extracted and added. The result, that is 20 plus 12 equal to 32, gets stored back in the position a11. Similarly, the values of a12 and a22 are extracted next, and their sum, that is 56, is stored back in the position a12 in the next iteration. Further, the values of a13 and a23, that is 20 and 15, get added as 35, which is stored back in a13. Finally, the values a14 and a24, that is 23 and 54, get extracted and added. The sum 77 is stored back in a14. The next loop displays the content of the array a1, which in this case is 63, 32, 56, 35 and 77. Next, let us take a look at another example. In this example, I will show you how the elements of an array can get reversed. On executing the statement int I a1n temp, two variables I and temp get created and 4 bytes of memory are assigned to each of them. Now, along with the two variables, another 5-celled array is created which acquires 20 bytes of space. The loop then further executes and it stores the values in the array. Now comes the part when the code is responsible for the reversal. As it is observed, the loop starts from 0 and extends till the middle of the array. Why middle of the array? If the loop iterates till the end, we will end up reversing the entire array twice. This is a very common mistake that I find students often make. So, in the first iteration, the value of I is 0 and 0 is less than 5 by 2, that is 2. So, the control enters the loop. In this iteration, we will swap the values 12 and 54. Using temp as the temporary variable, we swap them such that at the end of the first iteration, the content of the array becomes 54, 32, 25, 45 and 12. In the next iteration, I is incremented to 1, and since 1 is also less than 2, the control enters the loop further. In this iteration, we swap the values 32 and 45 using temp as the third variable. Thus, we get 54, 45, 25, 32 and 12. Next, the value of I again gets incremented to 2, but 2 less than 2 becomes false. So the control breaks out of the loop and moves to the third loop, which displays the content of the array. Now, if the value of n was 6 instead of 5, will this code work? Pause the video and put the answer in the comment box and then continue. Well, according to me, it will work. In case n is equal to 6, n by 2 will be equal to 3. So the loop will get executed from the values of I equal to 0 to I equal to 2, both inclusive. For I equal to 0, the first and the sixth element will get swapped. For I equal to 1, the second and the fifth element will get swapped. And for I equal to 2, the third and the fourth element will get swapped. So yes, this code will work for any value of n, irrespective of n being even or odd. In our next example, I will show you how we can left circularly rotate the elements of an array. Firstly, the statement int I temp arrn creates two variables I and temp and an n-celled array arr. Since n is defined as 5, arr has 5 cells. Next, the for loop is responsible for storing data in the array. Now, when temp equal to arr of 0 is executed, the content of arr0 gets copied into the variable temp. The for loop given next is responsible for left shifting the elements of the array arr from the first cell to the n-1th cell. So first, 45 gets shifted, followed by 25, then 32, next 12, and finally 54. The loop stops here as the value of I now becomes equal to n-1. That is, the condition I less than n minus 1 becomes false. After this, the statement ARR n minus 1 is equal to temp gets executed, which now stores the value 54 in the last cell of the array. Finally, when the last loop of the code gets executed, we find that all the elements of the array have been shifted left circularly. With that, we come to the end of today's video. Please hit the like button if you have enjoyed this video. Please subscribe my channel and share this video with your friends if you want to support this channel. And don't forget to hit the bell icon so that whenever I upload a new video, you are notified. Thank you for watching. Bye bye.